Okay, now I'm going to try to memorize some numbers. I'll ask you to help me. You can write these numbers down as they're called out to me. Just don't let me see them. I'll ask you to call out for me 16 single-digit numbers. Maybe the digits of your credit card, or it doesn't have to be that. So any one-digit numbers. And I'm going to try to remember them and call them back out without seeing the numbers. 5. 7. 3. 1. 8. 5. 9. 1. 5. 3. 2. 7. 1. 6.
3.
5, 7, 3, 1, 8, 5, 9, 1, 5, 3, 2, 7, 1, 6, 6, 3.
That's right.
Good. Thank you. In this lecture, my goal is to show you a fun and amazingly effective way to memorize numbers. This will help you perform very large calculations, and it will also help you memorize other numbers that are important in your life, such as credit card numbers, social security numbers, driver's license numbers, and so on. It can even be used to help you memorize numbered lists of things that aren't numbers at all, like who was the 14th president of the United States, or what is the 79th chemical element. For most of this lecture, we will take advantage of a phonetic code known as the major system, which has been in the English language for nearly 200 years. It's a standard technique used by memory experts throughout the world. I first encountered this technique in high school when I read a book called The Memory Book by two authors whose names I forget. Oh, just kidding. It was by Harry Lorraine and Jerry Lucas. The idea behind the major system is due to a German monk, Gregor von Feinagel, who presented his methods to audiences throughout Europe in the 1800s. The system was improved by a French memory expert, Aimé Paris, around 1820, and that's what we'll learn here. Most people's short-term memory can only hold on to about 7 plus or minus 2 digits. But with the use of mnemonics, like the phonetic code, this can be increased dramatically. In this lecture, I'll show you how to remember long strings of numbers in a fun and sometimes silly way, and apply it to doing larger mental calculations that were previously beyond our memory capacity. Okay. Here is the major system that we'll be using throughout the rest of this course. Here it is. For instance, 1 is the T or the D sound, the T or D sound. 2 is the N sound. 3 is the M sound, and so on. Now you may be wondering, well, how am I supposed to memorize that? There are even mnemonics for learning this list. The following tips were given to me by my friend Tony Marlashkevitz. Here goes. The number 1 is the T or the D sound, since when you draw a T, your hand goes down once. So a typewritten T has 1 downstroke. And if you can remember the T sound, you should be able to remember the phonetically similar D sound. The 2, for the number 2, it's N, and the N has 2 downstrokes. The M has 3 downstrokes, or if you put an M on its side, it looks like a 3. Or if you know sign language, the signs for T, N, and M are 1 finger, 2 fingers, and 3 fingers. Whatever it takes. The number 4 ends in the letter R is how I remember that 4 is R. Now 5 is an L. Now if you put the 5 on your hand and you look between your index finger and your thumb, you will see an L. It's cheap, but you'll remember it, and that's all that matters. The 6 is probably the hardest one to remember. It's the CH, SH, or J sound, the ch, sh, or j sound, one of the sneezing sounds. You might remember that by thinking that a 6, if you put it backwards, kind of looks like a J. The 7 is the K or the G sound, the k or g sound. Now that's a hard G like goat, not a soft G like giraffe. The giraffe G has a J sound, and we've already used that with the number 6. You can remember that the 7 is the K sound by realizing that a K can be drawn as a combination of two 7s, kind of a special K, if you know what I mean. The 8 is the F or the V sound, the F or V sound. A cursive F kind of looks like an 8, or you might think of a skater that does a figure 8. 9, that's easy to see, right? That's the P or the B sound, the P or B sound. You could turn your 9 backwards or upside down, either way. How about 0? How would you remember that that's the S or Z sound? The number 0 begins with Z. It's one of the hissing sounds, the S or Z sound. Another way to possibly memorize this list is just to remember the name of my friend, Tony Marlashkevitz, right? If you take the consonant sounds from his name, you get Tony Marlashkevitz is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I'll bet if I quizzed you right now and asked you for the sound of each number, you'd probably get at least 8 out of the 10 correct just by hearing these mnemonics once. With less than 10 minutes of study, you can learn this list backwards and forwards, inside and out. In fact, do me a favor. Right now, just take 2 minutes to study the phonetic code along with the memory tips. I'll put it here on the screen, or you can study your course guidebook. I promise that it'll be worth your while. After that, I'll give you a short quiz. But okay, I want you to pause right now and study this list, just for 2 minutes. Okay, we're back, and it's time for a quiz. Are you ready? Tell me, what sound does 3 make? With the phonetic code, 3 is the M sound, 3 downstrokes. What does 2 make? 2 downstrokes, that's the N. What number gets P or B, the P or B sound? That's the number 9. Okay, what number gets S or Z? It's the 0. Very good. Okay, what sound is 5? The number 5 has what consonant sound? It's the L sound. What number gets CH, SH, or J? The ch, sh, or j. That's probably the hardest one. That's the number 6, backwards J. Okay. What sound does 7 make? It's the k or g sound. Remember that special K that we drew with 2 7s. What sound goes with 1? 1 is the T or D sound, 1 downstroke, T or D. And what sound does 4 make? That's the letter R. And what number goes with F or V? That would be 8. Okay, here's a trick question. What number goes with H, W, or Y? I'm getting silence. That's good, because there is none. There are no numeric codes for H, W, or Y. There are no digits associated with H, W, or Y. Okay, and for extra credit, what's my friend's name? Tony Marlashkevitz. How many of those did you get? Once you know your code backwards and forwards, inside and out, you're ready to take the next step. Now that you've memorized your phonetic code, you have an invaluable tool for turning numbers, even meaningless random numbers, into words. We do this by inserting vowel sounds anywhere we'd like among our consonants. For example, suppose you needed to remember the number 491, perhaps in the middle of a big calculation, or maybe it's your hotel room number. How would you use the phonetic code? I would probably turn 491 into a rabbit. How do you do that? Well, 491, what are its consonant sounds? 4 is R, 9 is P or B, 1 is T or D. Now, by sticking vowel sounds wherever you'd like among those consonants, you can create words like robot or rabbit. Notice that even though rabbit is spelled with 2 B's, the B sound is only pronounced once. The number for rabbit is 491. It's not 4991. What else could you create? You could create words like repeat, or erupt, or orbit, or ripped, or rebate, or make 2 words out of it, like rip it. Now, in the phonetic code, as I said before, there are not digits used for the consonants H, W, or Y, so you can use those consonants whenever you want. So if you wanted to, for 491, you could stick a W at the beginning and create a word like warped. Notice that even though a number might have several words that represent it, each word can only be turned into one number, and that's important. Rabbit can only be represented by 491. Okay, here are some more words. In fact, let's do the opposite problem. Here are some words that are not created by 491. Okay, like party. Party would be 941. It's the P, the R, the T sound, and order definitely matters. So you couldn't make party out of 491. Or ramped. The ramped has an M sound, so we'd have 4391 in between. Or report. Report. What are the consonant sounds? R, P, R, and T. That would be 4941. Or take a word like repeated. That would be 4911 because the TD sound is literally repeated. Okay, time for another quiz. Give me at least 2 words that you can make from the number 36. You can pause to think about it. If it helps, what are the consonants for 3 and 6? 3 is M, 6 is CH, SH, or J. So what words could you create out of 36? Words like mash, or mesh, or mush, or mushy, or match, or magi, or image, or if you like proper nouns, mitch, madge, midge. Any of those are fine. Okay, now do the reverse problem. I'll give you a word and you give me its number. Feel free to pause after each question. Okay, fast would be what number? The consonants are F, S, T, so that would be 801. Mental would be what? M, N, T, L, 3215. Memory would be 334 for MMR. How about Chekhov? Chekhov would be CH, K, and V. That would be 678. How about a word like carry? Carry would be 74, not 744. Remember, when you use the phonetic code, spelling doesn't matter. All that matters is pronunciation. So the number 744 could be a word like career or courier, where the R sound occurs twice. You can use the phonetic code to memorize dates. For instance, to memorize that Columbus discovered America in 1492, let's see, 1492 is TRBN. You might turn 1492 into the word turban and picture Columbus wearing a turban as he crossed the ocean, perhaps with a turbine engine. Here's a hard one. Pseudonumerology. Give up? Pseudonumerology is 0, 1, 2, 3, 4, 5, 6, and give up is 7, 8, 9. To remember that Andrew Jackson was elected President of the United States in 1828, we could turn 1828 into TFNF. You might picture Jackson as a tough guy with a knife. Or to remember that the Gettysburg Address was written in 1863, that's TFJM. You might think that Lincoln wrote it to get out of a tough jam. You can use it for phone numbers. Suppose your friend Fibonacci had the phone number 235-813, then 2. Those you might picture using NML for the first 3 digits. You might picture Fibonacci riding an animal. And who was on that animal? 8132 is FTMN. He might be there with a really fat man, or maybe while chewing on a vitamin. By the way, there are plenty of free websites out there that have converted entire dictionaries into phonetic code. Just search on the words like major system and memory. That's how I found the word vitamin in my last example. I use the phonetic code to memorize my passport number, most of my credit card numbers, and the Social Security numbers of my family. Suppose you wanted to memorize Elvis Presley's Social Security number. Here it is, 409-52-2002. Now, looking at the phonetic code, if you wanted to break that number into 3 parts, 409 is RSP. You might get a word like raspy. 52 is LN. You might get a word like lion. 2002, I don't know any single words that would hold that, but you could get a word like 2 words, like in season. So raspy lion in season is Elvis's Social Security number. If you're given a really long number, like a 16-digit credit card number, then it pays to look inside the number for particularly long words, since the fewer words you use, the easier it is to remember. For example, here are the first 24 digits of pi, the mathematical constant that we know and love. Now, looking at pi, I see inside of it a 1415, that's a TRTL, and I see a 6264, that's a JNJR. I see some really juicy 4-digit words like turtle and ginger that we can make from those. Putting it all together, we can construct a sentence like, my turtle poncho will my love pick up my new mover ginger. My turtle poncho will my love pick up my new mover ginger. Say this sentence about 5 times and you'll probably have it memorized. And if you have the phonetic code mastered, then you now know the first 24 digits of pi. Now, I admit there are times when I don't use the phonetic code to memorize numbers. Let me show you some of these situations. Suppose you had the following credit card number. You might call it an E card since it's the first 16 digits of the mathematical constant E, 2.7, 1828, 1828, 4590, 45. I still remember that number using the method that my calculus teacher taught me long ago. He said, 2.7, Andrew Jackson, isosceles right triangle. What does that have to do with E? We have 2.7, then Andrew Jackson was elected in what year? He was that tough guy with a knife? 1828. So I have 2.7, 1828, 1828, and the angles of an isosceles right triangle are 45, 90, and 45. We use the phonetic code to learn the first 24 digits of pi with my turtle poncho, but I prefer to memorize it by reciting the first 14 digits with music instead. You might even recognize the tune. It goes like this. Pi, pi, mathematical pi, 3.141592653589. A good old fraction you may hope to define, but the decimal expansion won't die. Sorry about that. The phonetic code can also be used to memorize any numbered list of objects. For example, let's learn a method that would allow you to remember each president's number. Like Lincoln was president number 16, and the 7th president was Jackson. This method is called the peg system, and it converts each number on your list into a tangible, easily visualized word called the peg word. Think of putting a peg on a wall and being able to hang your word with that on that peg. Here are my peg words for the numbers 1 through 10. Here they are. Tea, knee, moo, ear, oil, shoe, key, foe, pie, and dice. Notice that each of these words is represented by their corresponding number. 1 is T. 2 with the N sound creates the word knee. 3 with the M sound creates the word moo, and so on. So, the first word on my list might be drinking tea. Or the second item could be on my knee, and so on. So, to remember that the first president is George Washington, you might picture yourself drinking tea with George Washington, or maybe washing a ton of clothes in a giant tea bag. The second president is Adams, and I might picture my knee being blown up by an atom bomb. Or picture my knee smothered with little atoms. Or maybe I should say tiny atoms. The third president is Jefferson. And the word for 3 is, what's the peg word for 3? M is moo. I might picture my friend Jeff with his son dressed in a cow costume saying moo. It's perfectly fine to create associations that only make sense to you. It's fine if some of them are silly or bizarre. In fact, that might make it even easier to remember. If your list has more than 10 objects, like, say, the presidents of the United States, then you need more peg words. Every 2-digit number can be turned into at least one word. So 11 is tot, 12 is tin, 13 is tomb, 14 is tire. I could give you all of them, but I encourage you to come up with your own peg words, since the first word you think of now is likely to be the first word you think of later. If you can't create a word for a given number, then go to one of the online major system dictionaries and they'll give you plenty of options. How would you remember that Franklin Pierce was the 14th president? My peg word for 14 is tire. Right? 1-4, T-R is tire. And so I might imagine the tire is being pierced, perhaps by Benjamin Franklin. Hence, the 14th president is Franklin Pierce. Which president was James Monroe? I might think of a giant wad of money rowing through oil. And since oil is the peg word for 5, I can remember that Monroe is president number 5. Who was the 40th president? My peg word for 40 is rose. And you might think of a red rose, and that RR might be enough to remind you of Ronald Reagan. Or for something even sillier, you might picture a giant rose pointing a dangerous ray gun at you. I can tell you from experience that if you use a list a lot, like say the president's, or a particular credit card number, then eventually the phonetic code fades away and the numbers are converted to long-term memory. Or you remember the numbers using other contextual information. For example, if it's already hardwired into your brain that Abraham Lincoln was the 16th president, and you know he was followed by Andrew Johnson, then you automatically know that Johnson was the 17th president. You won't have to picture John and his son quacking like a duck. My peg word for 17 is duck. Although if you know about Andrew Johnson, you might think of him as a lame duck president. Now, I've applied the peg system for learning where various elements appear on the periodic table. For example, gold is the 79th element, and from 7-9 you can make words like cup or keep. So you might picture a gold cup, or you might think that gold is something you want to keep, perhaps in a cup. You can use the phonetic code to provide more security to your computer password by adding extra digits. For instance, if you have one password that you like to use, like bunny rabbit, but you want to make slight alterations for each of your accounts, you can do something like take your standard bunny rabbit password, and when logging into the website for, say, your Visa card, you might include the digits 80741, which is the phonetic code for Visa card. Or for your PayPal account, you might include the digits 995. Okay, do yourself a favor. After this lecture, I want you to pull out your most frequently used credit card or ID number that you don't yet have memorized, and I want you to memorize it using the phonetic code. In the long run, this will eventually save you tons of time. The phonetic code is especially handy for numbers that you need to memorize for tests or for newly acquired phone numbers, addresses, parking spots, hotel rooms, and other numbers that you're just going to need for a short while. I find the phonetic code to be very useful when doing large mental calculations, and I'd like to illustrate that here. For example, let's try to square the 4-digit number 4,203. Our big picture strategy looks like this. We take 4,203, the nearest easy number is 4,000. So I'm going to go down 203 to 4,000. I now have to go up the same distance to 4,406. So the first part of my calculation is I do 4,000 times 4,406. How do we do that? I do 4 times 4,406. Now that's a 4 by 1, but we can do that. 4 times 44 is 176, and 4 times 06 is 24. When I attach those together, I have 17624. That is to say, 4,000 times 4,406 would be 17,624,000. Okay, now you want to take a mental break here. You've got 17,624,000. Now, you can actually say 17 million at this point. You can actually say it and get it out of your memory. I'll tell you why you can do that in Lecture 11. But before we do our next calculation, I need a way of holding on to 624. So how am I going to do that? Well, I don't have enough fingers to hold on to a 6 and 2 and 4. So it's the phonetic code to the rescue, right? 624, we can turn that into a word. 6 is the J sound, 2 is the N sound, 4 is the R sound. So 624 can be turned into a word like junior or January, or shiner, or joiner, whatever it takes, okay? I'll think of junior. That was the first word that came to my mind. Junior, I'll say it a couple of times. Okay, next I have to do a new math problem. I have to now add the square of 203. And that's going to take all my attention. But luckily I'm holding on to Junior, so I don't have to remember 624. It's a lot easier to remember Junior than it is 624, especially while I have a lot of other numbers flying around. Junior is not going to turn into Senior. It's going to stand out like a sore thumb. Okay, so my next calculation I have to do is 203 squared. How do we do that? To do 203 squared, we go down 3 to 200, up 3 to 206. 2 times 206 is 412, so 200 times 206 is 41,200. Almost done. We add to that the square of 3, which is 9, to get 41,209. 41,209. I'm going to take that 41,000 and add it to what? Junior, of course, right? But before we do that, I need to find a way to hold on to 209 because I'm not ready to say those numbers yet. So I'm going to hold on to 209 by turning it into a word. Now the sounds for 209 are N, S, and P or B. So you can make words like no soap, or no sub, or nose up, or newsboy. Okay, so let's go with no soap. So 209 becomes no soap. So I've got 41,000, no soap, and I'm adding that to what? Junior. Okay, Junior. Okay, 41,000, add that to Junior. Junior is what number? Using the phonetic code, Junior is 624. Add 624 plus 41 from left to right, we get 665,000. Go ahead and say it, get it out of your memory, and now finish up your answer with no soap. And no soap is the number 209. We can say that. And phew, we've just said our answer, 17,665,209. We'll see more calculation examples that use mnemonics near the end of the course. But before we do that, let's end with a simpler and more important application, remembering birthdays. Do you remember the date of Abraham Lincoln's birthday? I'll give you a hint. Some restaurants observe Lincoln's birthday by serving no tuna. Now, no tuna converts to the numbers 2 and 12, and Lincoln's birthday was February the 12th. Now, if you want to remember the year of his birth, 1809, those have the consonants T, F, S, P. You might believe that these restaurants suggest that since they sell no tuna, you might try their tofu soup instead, and tofu soup is 1809. By the way, February 12th, 1809 was not only Lincoln's birthday, it was also the birthday of Charles Darwin. Speaking of birthdays, once you know someone's birthday, it's very handy to be able to figure out its upcoming day of the week. I'll teach you how to do that in your head in our next lecture. In fact, with just a few easy calculations, you can determine the day of the week of practically any date in history. And I'll see you then.